Hey folks, and welcome to Build 2022. You've seen some amazing demos, big surprises and announcements, and in this talk, you're going to hear all about the Snowflake SQL REST API and how to use it with Postman. My name is Daniel Myers, Developer Relations here at Snowflake, and I'm super excited because we're actually going to be able to show you live how to build these applications with the Snowflake SQL REST API and how you can do all sorts of automation and development with Postman and this API together. So with me, I have the one and only Joyce Lin, Head of Developer Relations at Postman. Joyce, how are you?
Good, thanks Daniel. It's really exciting to be here, and shoot, I didn't realize we were going to do it live. Is that still the case?
Absolutely, so be ready.
Okay, well it's a pleasure to be here. I work at Postman, an API platform used by more than 20 million developers, so I'm really stoked to be here to represent the API portion of this summit.
Fantastic, and so to really start this off, let's look and see what all we're going to cover today. First off, we're going to show a Snowflake overview specifically through the lens of a developer and what are the different considerations that you'll look at, some of the tools that you have access to, things like that. Next is looking at the Snowflake software ecosystem. So understanding what programming languages you can use with Snowflake, what SDKs and drivers and connectors do you have access to with Snowflake. And then we're going to actually go a deep dive into the Snowflake SQL REST API, exactly what calls you can make, the different parameters that you have, how to authenticate, all sorts of things like that. Next, we're going to do an actual Postman demo using this REST API of Snowflake with and inside of Postman. And lastly, you're going to be able to do all of this demo, all sorts of open source material on GitHub. And we're going to go over exactly how you can do that, get hands-on with what we're showing you today. So let's get started. So it's important to understand that Snowflake is a global cloud network for your data. So it is a place that you can develop your applications with a data-centric mindset for all sorts of apps. And it is a single global unified system that connects your data with other providers and the most relevant data for your business. And this is important for developers because it enables you to develop the applications that you need and want to do for data-intensive applications. And so what actually powers this? It is the Snowflake platform. And under the hood, what you have access to here is an architecture that is multi-layered, from the centralized storage layer to the compute layer, which is both separate. You can scale both of those layers separately, which is very important for the ongoing management and maintenance of your application. It's also where you can have multiple different workloads from applications, data science, ML, cybersecurity, even data engineering and collaboration. These are all different workloads that can run on top of Snowflake and make it easier for you to develop data-intensive applications for your customers. And so you can, through the ingestion of unstructured, semi-structured, or even structured data, all sorts of data you can ingest no matter what it is, no matter where it's located globally. You can ingest that data, query that data, and make sense of that data in your application. So you can have all sorts of insights. You can do custom ML predictions. You can monetize that data on the Snowflake marketplace and build all sorts of different data products on and with Snowflake. So how does this relate to all the sorts of different customers that we have? So this has been proven. Building data applications, building applications in general with Snowflake has been proven by thousands of our customers today. Everything from Docker, Adobe, KFC even. These are all different customers of Snowflake that have built applications with Snowflake. And so let's take a look, and through the lens of a developer, what are some of the things that you think about when developing your application with Snowflake? Well, one, you want to be able to develop your application in the language of your choice. And for that, we provide several different first-party drivers or SDKs that you can leverage when developing your application. Everything from Python, Node.js, Go, you name it. We have many times a first-party native driver or SDK in that language for you. And so when we take the next step here with the SQL REST API, what does this allow you to do and enable you to do? Well, it's the REST interface version of many of these drivers and the features that they provide. So it enables you to interact and engage with Snowflake from any language, even if we don't have a native driver or SDK in that language for you to use. It is the language agnostic way to submit your queries and retrieve the results of your SQL queries on Snowflake. And this has been a common request from a lot of developers because they want to be able to build these custom REST APIs on top of Snowflake. They want to migrate existing applications that are REST-based into Snowflake. And this API, this REST API for Snowflake, enables you to do that. And so with that, what are some of the biggest use cases for the Snowflake SQL REST API that we've seen? Well, one is IoT devices. IoT device is a very common way for you to leverage the REST API because if the native driver SDK that we provide is too large, for example, for a microcontroller, you can still many times use a REST API on that microcontroller. And this enables you to directly ingest data from an edge device into Snowflake. The other big thing that we've seen from a lot of customers is building out these custom client libraries in languages that we don't have a native driver for. So if you wanted a Rust library, you can do that with the SQL REST API for Snowflake. Lastly, we also see a lot of times third-party plugin modules. This is where maybe it's a third-party application that has its own plugin architecture, and their interface is strictly REST-based. And so they require the plugin to leverage REST APIs to develop that plugin for that application. This enables you to build those plugins that leverage Snowflake in a REST-based environment. And so Joyce, as you see this, and what are some of the biggest use cases that you see folks use Postman for in your space?
I mean, I'm super biased, but I'm always of the belief that APIs are critical to have. So you guys have a lot of drivers. That's fantastic, and people can plug and play and use them right away. But those custom scenarios, I think, are what people want to be able to build. So people will use Postman to learn and explore what even is Snowflake's API like, or I can't get it quite to work, so I'm going to test it in Postman and then start layering on the sequence of API calls that they need for their own specific use case.
That's great. That's great. So let's take a deep dive look at what is included in the Snowflake SQL REST API. And the cool thing about this is that Snowflake lives and breathes in the cloud. So when we're developing this API, we use it ourselves. We dog food it ourselves. And so we've learned a lot about REST APIs. And so what we've been able to do with this is actually the entire API consists of 3 calls. That's part of the beauty here. So those 3 calls consist of submitting a SQL statement, retrieving the status or the result of that SQL statement, and if you need to, you can cancel an existing and running SQL statement. So let's take a deeper look at each one of these on what query parameters there are and some of the different development considerations for each one. So when submitting a new SQL statement, there's a few query parameters that are very important to keep in mind. First and foremost is the request ID. Why is this so important? So with a request ID, it allows you to have an idempotent request to Snowflake. This is especially for a database where your SQL statement could be inserting data or it could be deleting data based on whatever SQL query that you're doing. And so what you don't want to happen is, say it's an IoT device with an unreliable internet connection. You don't want to submit this call to Snowflake to insert data and then lose internet connection and you never get a response back. So at that point, you don't know, has the data actually been inserted or not? With an idempotent request, with a request ID, this guarantees it, that Snowflake, you can submit it multiple times, but Snowflake will confirm that the request ID is not duplicate, meaning it won't actually execute that request multiple times. And then second is the async parameter. This actually changes the behavior of Snowflake and how and when it responds to your call. In practical nature, what this means is that if you set async to false, Snowflake will actually wait the duration for the results of your query to be completed before actually responding to your REST call. On the contrary, if you set async to true, Snowflake will receive your REST call, instantly respond with saying, hey, I have received it, and this is the statement handle that you can go and request the status of it later or get the results of this query later. This is very useful for when you have long-running queries. And so it's a great way to be able to submit multiple queries and wait for those results whenever they come in. And lastly is the nullable parameter. This is useful for actually defining how the return object looks and is structured when retrieving your results. In particular, it will replace the null value with a string null, depending on what your preference is and what your application is expecting. So that is all about how you submit a new SQL statement. Next is actually retrieving those statements' statuses and results. So again, here you see a couple query parameters, but also a path parameter. In this case, the required path parameter is that statement handle. So I mentioned before, when you set async to true, Snowflake will instantly return to you a statement handle that you can use to then retrieve the results at a later time. And so that statement handle is the ID of the result set, of that eventual result set, essentially. So you'll be able to fetch the result set and query and pull for it as it's running. Next is that request ID and partition. So you still have that request ID, so you can keep this call idempotent as well. But the partition, this is essentially very similar to pagination and a pagination-based API. The difference between pagination and a partition is that a partition has a variable number of returned rows per page. So in this case, you could have a partitions collection set of 10 different partitions, and each individual partition in that result set could have, one could have 10 rows, the other could have 100 rows. And so that's the biggest difference, is that the result set, each individual partition could have a different number of rows returned. So lastly, let's take a look at canceling a long-running SQL statement that you want to cancel. In this case, you still need to have that statement handle, because that is the ID that you'll actually be canceling. And then you have that request ID, so you can go in and have this idempotent as well. So if a particular reason you only want to cancel it at a certain moment in time, but if it doesn't get canceled, you don't want to cancel it again, you can definitely do that. So that is it. Those are the 3 calls for the Snowflake SQL REST API. And the beauty here is that because you're submitting SQL statements, it means you can almost do almost anything on Snowflake that you can any other way, because almost everything that you do in Snowflake is through SQL statements. So being able to submit these and return the results means that you have a lot of power through this small surface area REST API of only 3 calls. Pretty powerful stuff. So from here, there's really an API playground. And when I say API playground, it's really a collection of 3 things. The actual Snowflake REST API, there's an open source Open API spec that you can download and use today in all of your projects, as well as a collection that's published directly on the Postman Explore pages. And this is where I want to really, Joyce, learn more about some of that and get a deep dive on how can we use Postman to automate and really play with this API.
Well, I'm excited to learn. Is it my turn now?
Yeah, let's do it.
I was a little surprised when I first saw your API. Just 3 endpoints, very simple, very modest, but then you have all the flexibility in your SQL statement. So the first thing I would do, I'm logged into Postman here, so let's get started building. The first thing I would do is actually search for Snowflake. So Daniel, is this you? Is this you, Snowflake?
That is us, yeah.
Yeah, so there's an official looking public workspace here. I'm just gonna click through. And if you're following along at home, you're welcome to do this. You should be able to follow along. I see you have a V1 that looks deprecated and a V2. So here, we saw earlier, here's those 3 modest but powerful endpoints, right? So what I'm gonna be doing if I'm following along at home is I'll go to the 3 dots and I will create a fork. And so Daniel owns the Snowflake public workspace, but I want to fork a version of that collection to my own workspace so that I can tinker around and explore and update parameters and that kind of thing. So I've already done this, so I'm not gonna hit fork collection, but you can do that if you're doing it at home. Let's go back to the search results. I actually have a workspace here under Postman DevRel under Snowflake build, so let's take a look at that. Okay, so I've already forked your collection here, and I've also created my own collection that includes a quick start. So I wanna get started with Snowflake in Postman. And on the right, I can see what's in this collection, and I can read down and say, here's what I need to get started. So I need a base URL. I logged into the Snowflake console, and I got that. And I also need a token, because I don't want just anybody to access and start generating SQL queries against my database. So I can click through here to see how to do key pair authentication. So I wanted to generate a JSON web token. Is that the best route, you think?
Yes, I would say so.
Okay, so I've already downloaded SnowSQL, and let's just list what I have in this directory called Snowflake. I've already done this where I generated a public and a private key. You can see those files there. And I'm going to execute this SnowSQL statement that points to my private key to generate a JSON web token. And here's my cloud account. I'm generating a token for user Jalen. However, if I was working with Daniel and I wanted to create a test profile, I could generate a test user and then share the credentials with Daniel. But nope, I'm not gonna share it with you right now. So I'm gonna hit execute, and I've encrypted my passphrase. You can't see what I used. Okay, please jot this down. I'm gonna be asking for this. No, I'm just gonna copy this to my clipboard and then pop back on over to Postman. So if I'm never using your API before, I can go and read through here, but I know where this is. So let's click on the collection, tab over to variables, and find token variable. I'm gonna go ahead and paste my token right here under current value. And this is super important in Postman at least, but like in anything, you wanna keep your private variables private. Current value is just for me. If I wanted to share with my team, I'm in a public workspace now. I could leak my secret to everybody. If I wanted it to leak it to public, I would put it here under initial value. Okay, very, very important. And I'll hit save right there. Okay, so let's load up our first call. You were talking about a post to create and execute a SQL query. So let's hover over these variables. The double curly braces imply a variable in Postman. So you can see when I hover over it, it's reading in a variable at the collection level. That's my cloud account. And the UUID I have is that unique request ID. So what's that word you said?
Idempotent.
Idempotent. Yeah, so if I have an IoT device, I don't want to keep pinging and having duplicate queries. I want to stay nice and lean. So here I'm going to generate, this is kind of fancy in Postman. You can copy and paste and put in your own unique identifier, but in this case, I'm writing JavaScript here in the pre-request script. This is JavaScript that will execute before my main request articulated here, and all I'm doing is using JavaScript and Postman to generate a unique identifier, and then setting it as a variable so then I can retrieve the results later. Okay, so if I go ahead and hit send, let's hope that token was activated. Let's hope I have internet connection. Okay, so I just executed my first SQL query. If I look under the body, this is just a sample body that I sent. I'm hitting the Snowflake sample data database in Warehouse S, and this is my query. It's pretty simple, but if you know SQL, you can have that query, you can have that statement to be anything, right? So here we see the response data, 200 OK, HTTP status code, and let's inspect our response. Here's that partition info. You said it's similar to pagination, row type, the actual data, and then if I get to the very bottom, here's that statement handle that I'll need in my path parameter to retrieve the results in the checking of the status. So I could copy and paste this into my clipboard again. However, we now know how to get and set variables in Postman. So under the test tab, again, this is JavaScript, I've actually captured that response body and I'm parsing it, so I now have a new variable called statement handle. In fact, let's just check that to make sure I didn't mess up the code. So I'm going back to the collection, and under variables, I now have that unique identifier here under current value and a statement handle. Okay, so let's go to that next get call. This looks very, very similar. In this case, it's a get, and here's my UUID, and here's my statement handle. If I hover over statement handle, we're going to be getting the status. Now, we already know what the status is, I think. It's 200. Okay, so here's that information again anyways. So you were talking about kind of a unique use case, and I'm not a data person, I'm an API person, and part of the magic of APIs is you could do pretty much anything with those 3 API calls. Okay, So let's clean up these tabs. I want to see if you've seen this before. So I'm going to collapse the quick start folder, open polling. I don't know if this is the right word for it, but it's basically periodically checking to say like, hey, are you done yet? You done yet? So let's go to SQL query overtime. Okay. That got dragged out of order. So let's load this up. We had an example SQL query. Let's look under the body. And now we have a slightly different SQL people at home. Tell me if you know what this means. Do you know what this means, Daniel?
So this query in particular will be generating a table of essentially randomized data. And it will generate it specifically over 20 seconds. So however many rows it can generate in 20 seconds, it's going to last. So this query is guaranteed to run for 20 seconds long, and it's going to generate as much random data as possible, essentially.
Okay, so I have 20 seconds. This is simulating our long-running query. And the other difference I have is under the params, you can see that I've set async to true. Okay, what does that mean again?
So setting it to true means that it changes the behavior of how Snowflake responds. So when it's true, Snowflake will instantly respond after receiving your request, saying, hey, I have received, indicating that Snowflake has successfully received your request, and here is the statement handle for you to periodically check the status of it later.
And we're kind of manually setting this to 20 seconds, but that's, I mean, is that long? It's relatively long. So let's send off and execute our statement. Send. Okay, and so this time we got a 202 accepted because it's async true, right? So it says asynchronous execution in progress. Use this query ID. We already programmatically set those variables. Let's check the status. Has 20 seconds passed yet?
Not yet.
No. Okay, so it's 202 accepted. Let's dumbly hit send again. Nope. How many times? Like, okay, let's just, how long is this section?
There you go.
Oh, there it goes. Okay. So now we have a 200 okay. And we have all the same metadata that we had last time. And I was dumbly hitting send, and that's one way to do it, but let's talk about an automated way. So under the tests tab, you'll notice that when async is set to true, if the asynchronous query is still running, you get back 202, right? But once it's finished, you get 200. So let's take a look at the tests tab. This is where JavaScript will execute after the main request is run. Snowflake sends the server response. So here on rows 7 to 17, I'm just doing an if-else block. If HTTP status codes comes back 202, I'm going to do a set timeout function and just wait 3 seconds, okay? And then check again. Check every 3 seconds until I get a status code of 200, in which case I'm going to kick back over to that notification. And the notification can be whatever you want. It could be an SMS, it could be like a hauga, like whatever you want. So we can go through and step through each of these requests like we did before, but the cool, slick part of the automation is for this folder, I'm going to go ahead and do run folder. And so this is those 3 calls I have that will run in sequential order unless I did a little bit of JavaScript to trick it. I'm going to run it manually. And let's run it. Okay, so Postman sending that post call to Snowflake. It's getting to check the status. It's 202 accepted. checking the status again 3 seconds later, 202 accepted. If I could divide 20 seconds by 3 seconds set timeout, I would know how many times this check would pass. Let's see how accurate the Snowflake servers are. It's just going to keep checking until it gets a 200 status code. And there it goes. The very last check, it was 200. Statement is completed. And then now it will, only then will it send me my notification.
That's pretty cool. I love the level of automation and the customizability through JavaScript that Postman can do on that. That's pretty cool.
Yeah, so I mean, there's a couple ways to quote unquote automate it. One is to write the request and then send them on your own. The other is to run it sequentially like this. And then the other side of things, I just want to show you one thing. This is very powerful. I think a lot of devs, when they're kind of tinkering around, like let's just set async to false, see what happens, set async to true, understand what happens. Once you have your statement working the way you want, on the far right, you can generate the code here in whatever language. And Go's a dumb example because you guys have a native driver for Go, right? But what if I was using Dart or like some random framework? I can generate those API calls.
I love it. I love it. So, so from here, let's look at some of the next steps, right? From you as a viewer, where you can go to download and play with this API yourself, and some resources that you can leverage. So from here, biggest thing is you can go to api.developers.snowflake.com. From there, you'll see a direct link to run this inside of Postman. The other element here is you can complete the end-to-end tutorial. We call them quick starts. This contains all of the source code, links necessary to Postman, etc., for you to get up and running with the Snowflake SQL REST API today. So from there, I want to say a big thank you, Joyce, for joining me here in the studio. My name is Daniel Myers, and again, thanks for joining me.
Thanks for inviting me.
Stepped up your game! I've been using Snowpark, silly! It lets you build snowballs with confidence by removing data security and compliance barriers to production with consistent, enterprise-grade governance controls! Pretty cool, right? Wait, what? Frosty gets his own song! Why aren't we singing about Snowpark? The easy way to production for Python! Using pre-installed packages and automated dependency management and secure processing! How do we make that rhyme? Oh yeah! Speed! Woo! I built this myself. Nothing could go wrong. Oh no! Ah! Get into your Snowflake Snowpark! It's the only way to go! Woohoo! I'm going so much further!